Beneath our feet, a hidden world thrives. Ants, tiny yet tireless, are not just marching in lines, they are crafting vast subterranean cities with a level of organization that challenges our own understanding of civilization. These are nature's engineers, and their societies are built on a foundation of intricate collaboration and instinct. Each colony is more than a simple nest, it's a carefully orchestrated masterpiece, a testament to the power of collective effort and evolutionary design. These miniature architects shape their environment with a precision that seems almost intelligent, governed by principles that have been perfected over millions of years. Within these bustling underground metropolises, every individual is born into a system where purpose is predefined. The colony functions as a single, cohesive superorganism, with each ant playing a critical role in its survival and growth. At the heart of this complex society is the queen, the singular matriarch whose sole duty is to lay the eggs that sustain the colony's population. She is the genetic core, the silent ruler reigning from her protected royal chamber. Surrounding her are workers, the lifeblood of the city, who tirelessly excavate, forage for food, and tend to the young. Then there are the soldiers, often larger and more formidable, who stand as vigilant sentinels at the colony's entrances, ready to defend their home against any threat. This division of labor is not a choice, but an ingrained directive, a biological contract that ensures the seamless operation of a society numbering in the thousands, or even millions. Each ant contributes to a whole that is far greater than the sum of its parts, their individual actions weaving together to form a resilient and thriving community. The true genius of ant societies lies in their architectural prowess. Their underground cities are not random mazes of dirt, but sophisticated structures engineered for optimal living. Using nothing more than their mandibles and a profound understanding of soil mechanics, ants excavate intricate networks of tunnels and chambers. These are not merely pathways, but are designed with purpose. Some chambers serve as nurseries, where the temperature and humidity are carefully regulated to nurture the colony's precious larvae and pupae. Others function as food storage pantries, keeping provisions safe from decay and intruders. Deeper still, waste disposal chambers are designated to maintain hygiene and prevent the spread of disease. A crucial aspect of high-density living, perhaps most impressive, are their ventilation systems. Ants construct vertical shafts that connect to the surface, creating a natural airflow that circulates fresh oxygen throughout the deep, winding corridors and prevents the buildup of carbon dioxide. This passive climate control ensures the entire city remains habitable, a feat of sustainable engineering that is both efficient and brilliantly simple. The entire structure is a dynamic entity, constantly being expanded and modified to meet the colony's changing needs, ensuring its longevity and resilience against the elements. What is truly astonishing is that this incredible coordination is achieved without any central command or blueprint. There is no single ant overseeing the grand design, no foreman directing the workers. Instead, their collective intelligence emerges from the simple, instinct-driven rules that each individual follows. This phenomenon, known as stigmergy, is the secret behind their synchronized efforts. When an ant performs a task, such as excavating a pellet of soil, it leaves behind a subtle environmental cue. This cue, in turn, stimulates another ant to perform a related action, like picking up another pellet from the same spot. Over time, these small, independent actions accumulate and self-organize into complex, large-scale structures. Pheromones, the chemical language of ants, act as invisible highways and signposts, guiding their neighbors through the dark, labyrinthine city. A trail of chemicals can signal the path to a rich food source, warn of an impending danger, or recruit others for a construction project. It is a decentralized system where communication is embedded into the environment itself, allowing for a level of cohesion that appears almost conscious. This emergent problem-solving, born from the interaction of thousands of simple minds, is what allows ant colonies to function as a unified, intelligent whole. The specialization within an ant colony is a marvel of biological efficiency. Each caste has a distinct job, with physical adaptations tailored to their specific duties. Foragers are the colony's explorers and providers, venturing far from the nest in search of sustenance. They possess incredible navigational skills, using the sun's position, landmarks, and their internal compass to find their way back home. Once a food source is located, they communicate its location to their nestmates with remarkable accuracy. Meanwhile, nurse ants dedicate their lives to caring for the next generation. They meticulously clean the eggs, feed the larvae, and assist the pupae as they emerge, ensuring the colony's future is secure. The builders, or excavators, are the tireless construction crew, using their strong mandibles to carve out new tunnels and chambers, constantly expanding the city's infrastructure. And guarding them all are the soldiers, whose powerful jaws or chemical defenses are deployed to protect the colony from predators and rival ant factions. This intricate division of labor ensures that all essential tasks are performed simultaneously and efficiently, allowing the colony to operate like a well-oiled machine where every part is indispensable. Communication is the invisible thread that weaves the entire ant society together. Lacking sight, in their dark, subterranean world, ants rely on a sophisticated language of chemical signals. Pheromones are their words, their sentences, their encyclopedia of collective knowledge. When a forager discovers a bounty of food, it leaves down a trail of pheromones on its journey back to the nest. The strength and composition of this chemical message can convey not only the location, but also the quality and quantity of the food source, allowing the colony to mobilize the appropriate number of workers to harvest it efficiently. Different chemical signals are used to raise an alarm, triggering an immediate defensive response from the soldier ants. Other pheromones help ants recognize their own nestmates, distinguishing friend from foe in a world teeming with rivals. This constant chemical dialogue allows for the seamless transmission of vital information across the entire colony, enabling them to react in unison to opportunities and threats. It is a silent, yet profoundly effective, system of mass communication. The problem-solving abilities of these miniature architects are a testament to their adaptability and resilience. When faced with an obstacle, such as a flooded tunnel or a collapsed passageway, ants do not panic. Instead, their emergent intelligence kicks in. If a section of their nest is inundated with water, workers will form living chains with their bodies to rescue eggs and larvae, moving them to higher, drier ground. They can even construct living rafts, linking their bodies together to float on the water's surface until the flood subsides. When a tunnel is blocked, they don't simply give up, they immediately begin excavating new routes, testing different paths until a new, efficient connection is established. Their construction methods are also highly adaptive. In loose, sandy soil, they mix saliva with the grains to create a more stable building material, reinforcing their tunnels against collapse. This ability to respond collectively and creatively to environmental challenges, without any top-down instruction, is what makes their societies so robust. They are not just building static structures, they are engaging in a dynamic, ongoing dialogue with their environment. By studying these miniature architects, we glimpse the power of teamwork and instinct. Their societies remind us that complexity does not require a mastermind. Sometimes, it emerges naturally from the quiet collaboration of countless small minds. In a world where humans often struggle with large-scale cooperation, the ant colony offers a powerful lesson in efficiency, resilience, and sustainable design. From their decentralized communication networks to their self-organizing construction projects, ants provide a blueprint for solving complex problems through simple, collective action. They show us that with shared purpose and seamless teamwork, even the smallest individuals can build magnificent, enduring worlds. Their success is a quiet but profound reminder that true strength often lies not in individual genius, but in the harmonious power of the collective.